Heyo, we're live. Hello, everybody.
Hey
All five of
everyone.
you so far.
Hello.
This
We have
is
14 on Twitch.
all right. This is AASLR. I'm going to try this the best I can. Anti-siphon address space layout randomization. I got through most of that. Today's topic is what, Andrew?
Um, Today's topic is about defending your developer credentials for the cloud.
I'm
Yes, and I put
excited.
him on the spot when I called him out just then. This is Andrew Krug. He is one of our Antisyphon training instructors, and he's got some stuff to show us. And then we've got Serena here. Who, if you've been watching, Serena. Say hi, Serena.
Hello,
Thank you.
everyone.
All right, let's get into it, right, Andrew?
Yeah, I mean, we could just go straight into it here, but are either of you users of the AWS cloud?
Yes, I'm actually certified in AWS
Ooh.
Cloud. Yeah.
I am not, at least that I know of. There's
I
probably
am also
something.
not
There's probably
certified in
something I
AWS
use
cloud.
that uses AWS, but that's about as far as I go.
Yeah, so what I'm curious, like, what has been your experience like with that certification and like the guidance around developer credentials? Like, do you think it was adequate? Is this one of the certifications that covered that?
So I took the AWS Associates exam. So I skipped I forget the first one and just took the associate because I felt like if you had a decent amount of knowledge in like systems administration and networking, it wasn't too bad because a lot of times you're just kind of slapping on different names to these technologies you're already familiar with. Um, but I took this. I'm trying to remember what year I took this. It's been a couple years since I took it now, and I don't recall a lot of information on about developer credentials on AWS. But they do have a whole section on key management and key rotation. So maybe.
Okay. Well, the access keys are the credentials that we're interested in, and we'll be discussing at length today. That is the topic. Feel free, if you're coming in on YouTube or Twitch, I can see your messages in the chat. If you want to let me know if you're an AWS user, if you've ever had a credential leak, I'm super interested to know that. I think that a lot of people have like kind of survivor's guilt about credential leaks sometimes, but this is like one of the things that if you are at work in the cloud long enough, you'll probably have to deal with this at some point. So I dealt with this a lot when I was a security engineer, security practitioner. It seemed like almost every week somebody would come and say, "Hey, I accidentally committed this credential to GitHub. What do I do now?" And like, it really wasn't specific to any particular cloud. It happened across all three of the big cloud providers. But just kind of understanding, like, what do we do when that happens? How do we set things up to be really, really sure um, that when it does happen, it's not like game ending. And what's some of the tooling that we can just put around this to make life easier for people is kind of what I'm going to cover today. I know that sounds like very hygienic and boring, but it is one of the first things that we cover in the cloud security class because, believe it or not, something like 80% of publicly available data on breaches is related to credential leaks of one variety or another, either developer credentials, machine credentials, and those tend to kind of be the most impactful. So if we're not addressing that before we address the really interesting, super cool, machine learning, detection and response security stuff, we're really kind of setting ourselves up for failure. So I just thought I would kind of dive in here. This is the AWS console. If you've never seen it before, and by default, when you sign up for AWS, you get a what's called a root user account. That's what we're signed in as right now. And what you want to do is basically never ever use that account for literally anything other than to delegate access for someone else to see your bill, and also to set up a variety of other ways to interact with the environment itself. So if you have questions, kind of as we walk through this, definitely surface those. Somebody said, I've heard AWS was a thing once upon a time. Yes, I think that AWS is indeed a thing once upon a time. In fact, I think it's like a $700 trillion thing or something now. I don't know if anybody knows the exact last public revenue number, but it's insane the amount of money that is in cloud compute, which is, of course, why attackers are going after cloud compute and doing things like polluting the supply chain to steal developer credentials and all this interesting stuff that's kind of happening in the world. So if we come in here to the AWS console, this is just like a basic account that I use to teach the Antisyphon Cloud Security class. One of the first things that we have people do is just come into the account settings and turn on some good security defaults. And again, this stuff is generally made in a way that makes it really, really easy for you to use, because that is how cloud providers make money. It is not deployed in the way that is the most secure by default, or even onboards you in a way that's secure by default. So the fact that you have this highly privileged user when you sign in that doesn't even really have multi-factor authentication is a problem. So if we were to scroll down through all this, you can see like you have the opportunity to set up a whole bunch of contacts for billing and operations and security. You have the opportunity to turn on some challenge questions so that later on, when somebody wants to reset your password, they can bypass all your security. I always turn these things off. And then for the actual root user itself, you have a basic username and password. You can also have a key pair, though in theory, if you're never using this first very highly privileged account for anything, you should never even generate an access key for this user, because this is just kind of a recipe for disaster. There used to be a number of things that you could only do as the root user from an API perspective, but most of those have been delegated away. So this is one of those things where if you've had an account for a while, it's just kind of a good idea to pop in and make sure you don't have one of these keys. And then the other big thing, that I advise people to do is actually just turn on second factor authentication for this first user that you generate in the account. And when you do that, you have a few different options, right? Like one of these is virtual MFA. The other is to use a security key like WebAuthn or U2F. And the other is a Gemalto token. I always tell people for this user to actually just use the plain old TOTP, or the 6 digits that you put in to an app. So, and the reason for that is that you can't enroll more than one security key for this user. So if you were to lose your hardware key, you don't really have a back way to get into the account again. So by using a virtual MFA device, you can back up the secret that's generated. So when you pop this up, you can either scan a QR code to enroll an MFA device, or you can back up this key that then you can use with a command line app to generate those second factor tokens. I'm not going to enroll an MFA device right now. Somebody says AWS's revenue was $62 billion in 2021. So I was off by an order of magnitude, I guess, when I said trillion, billions, trillions. 62 billion doesn't sound like enough. Somehow that sounds like a quarter's worth of revenue, but I could be wrong. So when you enroll these things, this is effectively done. You can take the secret and put it on the shelf and then sort of transition off this and kind of go away. And then what we do after that is we actually set up regular, what we call IAM users. And these are the primary ways that people should be signing in to the AWS account and interacting from a developer perspective. And what we do is we set up a first user. In this case, the user is named Donna.Noble. If you ever take the Antisyphon CloudSec class, or you happen across one of my talks, you will notice that the user is always Donna.Noble, because Donna Noble is the name of my cat. And she's prevalent in the course material. So if you really like cats, it's also a great course to take for seeing lots of pictures of cats. So this user has a few interesting things kind of about it. It has more or less like full administrator rights, but only by doing this thing that's called an assume role. And we'll talk a little bit about how that actually works mechanically in just a while. But this user also has security credentials. And some of the attributes of that are that we have an MFA device also enrolled for this user. So this user has to sign in with second factor authentication. Again, this could be a U2F token, but in this case, for just simplicity in the class, this is just the 6-digit TOTP sort of sign-in. And also, this user has what are called access keys. And these access keys are the primary things that people are securing, they're trying to steal, they're accidentally leaking to GitHub. These are effectively the same as a long-lived username and password. So this is how we both generate these and also deal with these during a security incident. And hopefully everybody's kind of following along here. I'm going to deactivate the keys that I have because we last used these the last time we taught the cloud security workshop. So I'll go ahead and get rid of the ones that I have. Of course, it's not letting me paste. Let's see if this works. Paste. Wow. Okay. That worked. So that key's deactivated, and now we can go ahead and just remove it. So
they always change things right before a demo.
I know. The AWS console actually doesn't change that frequently, but it changes frequently enough that every time, like we teach the class about 4 times a year, and every time we teach the class, somebody very generously goes through and updates a lot of the screenshots. Because I keep a lot of the material, like the labs and the CloudFormation templates for the class in GitHub so that other folks can contribute. So if that's something that you're interested going and looking at, there you can go and pull those up on my GitHub. I may just also throw out a link to this on my Twitter as well a little later on. This is where all the CloudFormation templates are. And these are kind of made in a way that if you do take the cloud security class and later on you're like, oh, I kind of want to use that as the basis of something to implement at work, you at least have a really good starting point or a solid foundation that you can build on. So the first thing that we do, again, is we want people to be kind of as safe as possible in these environments, especially if they're brand new to the AWS cloud. We don't want them to accidentally leak a developer credential during the class and then end up having somebody spin up a bunch of Bitcoin miners or something in their account. So we set up this initial user. We set that user up with MFA, and this is all set up using a CloudFormation template that's provided to students as part of the class. And let's see if we can go and find that file. So yeah, the first user and the roles are part of that initial setup. And what's kind of unique about this first user is that this first user has a randomly generated password using some special syntactic sugar in like serverless that generates a random password for that user that's compliant with all password policies. And then we also bind a very special thing to the user called where is that? You can tell how bad I am at actually using the UI in here because I actually don't use the UI that often. Oh, it's bound to the role. So not only does this user have a policy that's attached to it that says the following, once it ever pops up, it says this user can do all of these actions, but only if they have logged in with a second factor credential. So kind of what we're doing here is we're really restricting what the user can do without that second factor. And then to actually become a privileged user in AWS, also the role itself, and we haven't talked about roles yet, but the role itself actually has this condition on it as well that says when the user assumes this role, which basically, if you've never heard of a role in AWS before, it's like putting on a hat of some kind that gives you superpowers to do a specific set of actions, and those can be as broad or as limited as you would like. When that user does assume that role, they have to provide two things, both proof that they signed in with a second factor, and that comes in the form of a signed session call. So the actual request to assume the role has a signature and attributes for the session context that says, hey, this person authenticated with a second factor. And then we also say in there that they have to provide attribution for who they are when they assume that role, because attackers actually will use assume role sessions to kind of hide their identity sometimes, because once you assume a role, all of the actions in that account are attributed to the role and not the individual. So this condition here just requires people to be honest about who they are when they assume the role. So the condition says that your username has to match the username of the IAM user that made the call in the first place. And that's a very long and fancy way of saying that you can't do anything with the credentials without the second factor, including assume privileged position in the account. Then we can do all kinds of other interesting things, like we can set the maximum session duration for privileged access, or we could put other attributes or other conditions on this, all the way up to and including these calls have to come from a specific IP address, or they can only do these things during specific times of the day. So you kind of get the idea here that we're really just trying to make a credential leak as not impactful as possible. And in just a second, I'm going to show you how easy it can be to actually use tooling on the command line that will put people through this second factor authentication, provide a great developer experience while still being really, really secure. Because I think for a while, in the very early days of AWS, and when I say early, I mean like circa 2012, 2013, using second factor credentials got a really bad reputation because it had really, really cumbersome UX on the command line, which is where all the devs are actually working, right? So I don't know if anybody's ever heard that or thought that before, that these were kind of clunky workflows compared to just having a set of privileged credentials, and it was actually slowing you down to the point where you decided, I'm just gonna YOLO this and do it the dangerous way. I think we've all done it at least once. I know I have. Doesn't look like any questions coming in on YouTube or Twitch, but we'll go ahead and we'll just go forward here with the demo. And so I totally feel good doing this next step on screen, because again, I have all these security features in place that are protecting this user. So I'm going to put some credentials up on the screen. And if anybody feels like stealing them and running and trying to do something with them, that's fine, because you won't actually be able to do anything with these credentials without a second factor. All right, so I'm going to generate a brand new key here. So if I go to security credentials, scroll down to access keys, I'll go ahead and generate a brand new access key, and I'm going to download this as a CSV. So there's my new access keys. And here I'll even show it on the screen, because I was really serious. You can't do anything with this access key pair. And then the next thing that we're going to do is we're actually going to set that up in AWS Vault. And if you've ever used AWS before, you are probably familiar with using the AWS CLI, but there's this other great command line tool called AWS Vault. And AWS Vault is an open source project from a company called 99 Designs. And it is just a awesome wrapper around doing the credential dance that you have to do with AWS in order to install different roles, or in order to assume different roles on the command line. And I will show you a bunch of different ways that this is cool, but it is packaged for every OS that you could ever imagine. So if you are new to AWS and you're a brand new company that's just starting up, you might want to consider just kind of adopting this as part of your access pattern for the way that you recommend people authenticate with the AWS cloud. So I've already installed this on Mac OS here using Brew. But let me see. I got to switch to sharing the terminal here. Let's do that. We'll switch to sharing the terminal. Here we go. And the reason I like this is not just because it has better UX. I also like this because it actually encrypts the credentials that you use using the operating system's keychain. And for a long time, we were actually seeing different malwares and stuff that would try to hunt down AWS key pairs on the box as soon as they were detonated, right? So it is a huge victory that we just don't even store the credentials in plain text on the disk when we're not using them. So what we'll do is we'll type AWS Vault add and then a username, Donna.noble. And then it just prompts me for that same access key pair. I'll go ahead and just paste it in here out of that CSV that we downloaded. You can't see this, but I'm grabbing these from another window. So I'll just go ahead and paste these in. And then there we go. And now it's actually, this is the first time I've ever done this on this machine. You can't see this window either, but it's actually popped up the Mac OS keychain, and it's asking me for a keychain password to authenticate with a keychain to decrypt the credentials. That's just the regular keychain prompt, but now they're actually stored in the vault, which I think is really, really cool. If we were to go and we were to look at the place where credentials live on the system, there's actually not a AWS credentials file even, which is really, really neat. And if we try to use these credentials the normal way that we would use them, which, like, does anybody on the YouTube stream know what the first AWS command is that an attacker likely will run when they get a pair of credentials? I mean, the answer in Linux is usually like, who am I, right? Because you want to see if you're root. So the equivalent of that in AWS is, of course, AWS STS get-caller-identity.
That's so much longer.
It is. It's super long, but we have no credentials on the system, right? So we have to run AWS Vault exec. And I think that there's a flag that we can pass. Yeah, AWS Vault exec Donna.noble, because that's the name of the profile that we just set up. And then the command AWS STS get-caller-identity. And it's actually prompting me for the password, which you can't see, but I'm going to go ahead and give it. And then look at that. We're actually using those credentials now safely that we decrypted out of the vault. So that's step one, right? Is that we're storing our credentials at rest in a secure way on disk that a malware or phishing, executable thing can't just go and snag and then go use to do something that we don't want. We also notably, if we try a privileged action right now, like we just let's try to make an S3 bucket, AWS S3 MB. We'll make the notorious S3 bucket. Access denied, because I actually can't do anything with this account other than run STS get caller identity. Because again, we have this constraint that's enforced that requires this second factor credential. And so the next thing that we need to do is we actually need to tell AWS Vault how to assume a role. And so the way that we do that, and just give me one quick second here to pull up an example.
Could you use that for like information gathering? Like if you accidentally leaked your credentials, but you could log and see every time someone tried to use them?
Yeah, so that is a great question from Serena that you basically just explained the idea of canary tokens.
Yeah.
So sometimes people will actually put a set of unprivileged AWS credentials like this in the open in places to see if attackers are reconning their environment, and then have a limit on any time somebody does what I just did against one of those tokens.
Cool.
You can also do lots of fun things with like impossible travel alerts for that, like when somebody doesn't follow the happy path. So let's say that they were performing this action without a second factor, and it was also an IP address that we'd never seen, like a new term for the source. That would be kind of interesting and potentially worthy of an investigation. So yeah, there's a lot that we can do to sort of leverage this.
Cool.
So what we're going to do is we're actually going to set up what's called a profile. And I find that a lot of people really aren't totally 100% firm on the way that this all works. But what you have on the AWS CLI, regardless of the operating system, it's the same for Windows, it's the same for Linux, is you have a config file that describes all of the different roles. And so you have a default, which these are the settings if you don't provide a profile, and then you have an infinite list of potential profiles. So what we're going to do is we're actually going to set up a second profile here. Oops. Leave vim in brackets. We're going to set up a second profile here that allows us to assume this administrator role. So I'm going to call this unfederated administrator, because it's an unfederated user, meaning that it's a user that's signed in using a set of credentials, at least initially, and it's coming in through a vehicle that's not single sign-on, because that's also an option in AWS if you already have a single sign-on setup, is to just kind of embrace a single sign-on flow, and we can do all these same things with single sign-on. We actually cover that in the class. It's just a little more involved setup. And so then these next parameters, again, we're forcing people to attribute who they say they are in that trust condition that we saw first. We're also telling it what is the source profile. So like what is the initial set of credentials that we're going to use to derive access? Then the next thing is the ARN, or the Amazon resource name of the role that we want to assume. I believe it's just called unfederated admin, which is the thing that I provisioned using the CloudFormation template that we referenced. I'm going to just double check that name. Actually, unfederated administrator. That is at least I was consistent. And then it's asking for the serial number of the device that we're using to authenticate. And that is all we need. And then that tells AWS Vault, we do an exec, which the way AWS Vault works is that it actually spawns a ZSH or bash prompt inside of bash or ZSH. And there's a way to get it not to do that if you don't like that behavior, but it's really handy for a number of reasons. The most notable of which is that it doesn't serialize a credential to disk, but also if you ever want to get out of an AWS Vault session that you're in, or let's say you want it to be in multiple, those can be individual sessions per shell, or if you want to drop it your privileged superpowers, if you want to remove them, you can just type exit, and it will exit the thread or the process, and then you're back to being a normal user. So that's pretty nice. But if we do this and we exec unfederated administrator, now it's going to actually prompt me for that second factor token. So I'm going to pull that up on my phone here because I've pre-enrolled this cooking show style in my Android here. So I'll go ahead and put that in. Ta-da! Now, if I do AWS STS get-collar-identity, it is, I'm actually in that privileged role. So now I can do privileged things, of course, like I can AWS S3 make bucket S3://demo dot is it AASLR? Because S3 buckets can just be any name. So I tend to make them match domains. And see, now we can do privileged things. So just by sort of taking this singular action here, we have made it so that if we accidentally did commit this credential to GitHub, nobody could do anything with it. And so just by having this like kind of guardrail in place, we've already made ourselves like 1,000% safer than most people are when they first turn on AWS and start using AWS. I don't know if there's any questions coming in. I'm switching back. Nope, doesn't look like any comments or questions. So I'll just go ahead and forge ahead here. The other thing that we can do to help keep ourselves safe from credential leaks is that we can actually scan our code repositories with command line tools that will identify if we've accidentally put access key pairs in our code, so that it actually never makes it to GitHub. So not only, in the unlikely event that it does get there, we are confident that the blast radius of that is not going to be super broad. We can also take steps to prevent people from doing it in the first place. And I'm sort of on the fence as to like whether this is effective or not, because it is, once again, it's a pre-commit hook. And I don't know if anybody here has ever used pre-commit hooks before, but they're not the friendliest in the world to set up from a developer tooling perspective, because they require the person who pulls the repository down onto their machine to take an additional action in order to put that pre-commit hook in place. It's not like you can just set up something where you say, every time somebody clones this, it's always going to have pre-commit hooks. It's an additional step. And some corporations, will put in place additional developer tools on the boxes that they control, so that some sort of management software will come back and it will add pre-commit hooks to the developer's Git setup. But that's not always happening. Not everybody has access to all those tools. So you just kind of have to invent your own blueprint or your own workflow for this. If we were to pull down, let's say, the securing the cloud supplemental materials and try and introduce a pre-commit hook to that, that's the thing that we're going to try next. And this is never before seen on a live stream by me. So who knows what's going to happen? Maybe it goes well, maybe it goes horribly wrong. I definitely didn't decide that this is what I was doing on the stream like 20 minutes ago. But this is what we're going to do today. And maybe if everybody likes it, like this will become a lab that I can put in the course later on down the line. So we have a Git repository. And what people don't always know about Git repositories is that inside of these folders is always a directory called .git. And if you go into .git, you can see a folder that's called hooks. And hooks have all of these different things that we can run as part of a commit. And operations teams have been doing this for a long time, right? Like maybe they want to run a linter or a code formatter or something like that. But we can also kind of hack this process for security stuff and things, as long as it's lightweight enough that we can run it on the developer's box. So checks that tend to work really, really well here are things that run really, really, really quickly, because again, it's going to run before the commit is actually stored, which means if you put something annoying in here, the person who's using it is probably going to take it back out. So we're interested in a pre-commit. So if we copy this pre-commit.sample, pre-commit, and then we edit that, see that there's a pretty nice template here that we can just use to kind of like work stuff out. And even without really knowing how this works, we can say, we can kind of see where our code needs to go. So the sample here is checking for allow non-ASCII characters in the default pre-commit hook. There is an audience question from Graham. So do hooks automatically run when you commit, or do you have to specify it each time? You only have to install the hook once. And then once you install the hook on your local, because Git works by syncing up binary diffs from like local to the remote, this is going to run every time you commit local. Now, some people go belt and suspenders with this too in their CI/CD workflows, and they actually will put in pre-commit hooks on the dev machines, and then they'll also put in a post-commit Git action or something that rescans the code just to make double sure that no credentials have actually made it into the source code repository. Somebody asked, how much has my class changed since the first time that we taught it? And the answer is not a ton. So we're still taking feedback on a volume 2 of the class. So if there's a thing, anybody that's taken it before, or anybody that has an advanced topic that they'd like to see, and I don't even really like to use the word advanced, but the first one is a foundations class, right? So if you're thinking about building that foundation, what would you want to see? Let me know. So what we're going to do here is we're going to actually try to install a pre-commit hook called Trufflehog. And if anybody is familiar with Trufflehog, or maybe you're not familiar with Trufflehog, it's kind of just like the go-to scanner for Git secrets. Lots of different secrets, not just AWS keys, but Trufflehog scans for all kinds of things. And vendors actually, to their credit, are doing a much better job of making their secrets discoverable, which I think is a really interesting thing that's evolved out of all of these credentials that are leaked and stuff. Because when the creator of Trufflehog started making Trufflehog, he had to, the best way that he could detect secrets was to just scan for high entropy strings. And if you don't come from a mathy background, high entropy just means that it's just a really random piece of garbage. And that could be great for identifying a lot of things. It could be great for identifying API keys, but it could also be, just like something that's actually a little bit more random than normal. So there was a pretty high false positive rate. So the vendors got back together and they started to say, well, in order to make secret leaks more detectable, we need to really make our access keys follow more predictable patterns, and we need to make them regexable. So you may notice that AWS access key IDs always start with AKIA, for example. So it's like AKIA, and then it's a fixed length after that. And so because vendors are sort of incorporating these basics now, we're actually able to do a lot more proactive scanning and even identify specific types of secrets using these proactive scanners. So we'll dive into to Trufflehog here. Downside of pre-commit hooks is that if you don't have a nice like pre-packaged binary, all the things that you need to run the pre-commit hook actually have to be on the system. Yeah, somebody who has taken the class rightfully points out that long-lived keys start with AKIA and short-lived keys start with ASIA. Which is something that we actually go over in the curriculum itself, the difference between an assume role session and a long-lived credential. So we're just going to install. Trufflehog is a Python package. Let's see if it'll just install. Hey, look at that. It just worked. That's how we like Python packages to be. So if you just run Trufflehog, now it's actually on the system itself. And so now what I'll do is I'll find a demo pre-commit hook for Trufflehog here. We don't need to invent the wheel or anything. Somebody else has probably done this. And it looks like somebody has, I think. There's plenty of Git issues in the Trufflehog repository that say that we can do pre-commits. And really all you don't have to do fancy stuff in your pre-commit hooks like the demo here. So if anybody remembers when we looked at this the first time, we looked at pre-commit here, it had like a whole bunch of bash shenanigans and different cases and statements. Let's just see if it actually even works if we just throw something really simple in here. So if we just get rid of all this garbage down here, I don't know if this makes anybody uncomfortable, but I know a lot of people that are uncomfortable if you just delete big blocks of code and comment them out. This is my favorite thing to do when I pair program with people, because this is why we have version control, so that we can just delete. So I'm just going to paste in this command, which is Trufflehog. We're going to run it against Git. We're going to run it against everything in this file path. And we're going to say for the most recent commit, because what we don't want Trufflehog to do is go back and scan all of time for the Git repository. So every commit is a binary diff. And Trufflehog can do that kind of research, and some people do use it. Both attackers and defenders notably use Trufflehog to just go and clone thousands and thousands of repositories from GitHub and then go back through the history to see if somebody leaked a credential and then just kind of covered it up with another commit. Always report to your security team when you do leak a credential. They are your friends, and they will help you. Don't just cover it up with another commit, because somebody will find it. Like, they will find that key. So here we go. We're going to try it. We can actually just / the pre-commit hook, because it's just a script again. Unrecognized arguments file : / dot. So that's the problem. Here, let's just try and run. Let's try and run this command manually. All right. Hey, look at that. It found some stuff. It found an image. So a great example of things that might be false positive for high entropy: images. So we can do better, I think. We can get this down to maybe just scanning for AWS keys. I don't know if anybody knows the flag for this offhand. If you do, just go ahead and throw it in the chat. But we want to kind of make this less randomy. We don't want these false positives. We like Trufflehog, but we really want it to not identify images. Here we go. We can use Trufflehog in regex mode, because, as I mentioned, we can scan for known bad regular expressions. So Trufflehog with dash dash regex dash dash entropy equals false should not identify anything in this repository right now because there are no access keys in this repository. But let's say that I moved in my file of long-lived credentials to this repo. Like this happens all the time while you're working, I'm sure. There are all kinds of things in development workflows that will generate temporary files. Thanks for the 15-minute warning, Ryan. There are all kinds of things that will generate temporary files that are full of credentials. And you can accidentally commit those too if they're not in the git ignore, or if you put them in Python. Sometimes they end up in debugging files for all kinds of reasons. So now if I run Trufflehog, it should actually hit on that file. Didn't hit on that file. That's unfortunate. So I think it's actually maybe the regex that's the problem. So Trufflehog, we'll just look for this again. First time, legit first time that I'm doing this demo live without some set of docs here. All right, so we're looking for. All right, somebody online suggested that I try it with these flags. Oh, no verification is not a flag in this version of Trufflehog. That is not the right answer either. These seem like bad flags to the actual Trufflehog scanner itself. So it has in theory, there's actually a regex detector for AWS access keys. I'll just broaden the window so you can see what it looks like. And it should look like that. So that's the actual Go regular expression for detecting access key pairs in Trufflehog. So let's go ahead and we'll keep trying to find the right command. Aha, maybe we have to pass it a rule file. Aha, so AWS has some prescriptive guidance on this. They want you to create a rule file of JSON that's common regexes for this is very useful. Look at this. These are all the common signatures that Trufflehog should look for all kinds of secrets, including AWS API keys. So particularly the long-lived ones, because those are the ones that we care about the most. So let's go ahead and give that a go. So we save that file there, and I will I'll tweet out some links after the session's over. So again, like if you want to follow me on Twitter, I'll go ahead and tweet the things from the stream. Let's go ahead and run this with this fancy new rule file. See if it will match. It didn't find it. Wow. So it should be finding this file. Like we literally have a CSV that is full of credentials right here. How it's not finding this, I have no idea. Maybe it's because we haven't appropriately provided it a file path. We did get it to run once. Did we not? Oh, it wants a Git URL. So it wants to actually clone the repository itself, which seems problematic because I want to run this locally. I think that get secrets are it says file : / I think this might be a Python problem. And now we start to see the problem with running this sort of tooling locally on the machine itself, because we're actually getting a Python error here. I think that we're providing the entire correct command, but we're actually getting a failure here because it looks like there's a problem with git exec, the Python module in my version of Python, which is 3.9. So in theory, this is also packaged. Oh, there's an issue with it on M1 as well. And I'm running on an M1 Mac. So we're seeing all of the challenges we might encounter actually trying to implement something like this.
That happens to me every time too.
Right. Right. There's some guidance here that maybe I shouldn't have used pip to install it. So let's uninstall it with pip, and let's try it from brew, and maybe we'll get a better artifact. Maybe the brew tap is better. Maybe it's packaged with a binary version of git. Oh, Python development. It's so fun to have things that are bound to C libraries. Oh, there's not a... Oh, you have to install the brew tap, because of course I want to add things to my software supply chain to use a security tool. Why wouldn't I? You only live once, right? Okay, so we'll try that command again. Oh, it does not like the regex flag now, so maybe I got a different version of Trufflehog than I had before. So let's see. Doesn't have a manual. Does it have a version? They said they wanted organic demos for these streams, so this is about as organic as it gets. One time during the class, we actually wrote a patch, like a pull request live for Duo Labs Cloud Mapper project, which was a really fun. That was a fun day where I felt like I knew how to security. Today, I am just not feeling like I know how to security. Okay, but maybe this Trufflehog is actually better than the last one, and we can run the original command.
I feel like this is the most realistic depiction, though, of what people are going to
This is your real life
when trying on their own, which I think is honestly kind of valid, because sometimes people feel bad when they run into all these issues because they'll watch a demo and it could be so seamless and perfect, and then they try it on their own and they're like, what am I doing wrong? And usually they're not really doing anything wrong.
Yep.
So
this Trufflehog that installs via brew does not have the regex flag at all, which is totally weird, because according to the documentation, it's supposed to have it. Oh, it's a deprecated flag in the latest version. So how the heck do we run this with a secrets file? I think maybe we actually just get rid of the regex altogether. We run it with a rules flag, which it claims to still have. Nope, there's no rules flag anymore either. All right. This is so real life. Somebody says, hey, go put pre-commit hooks in all the things, and then spend a quarter trying to put pre-commit hooks in all the things. Okay, so we'll try it with git. There. Finally. So that in the new version of Trufflehog is apparently so awesome, so much more awesome than the old version. You no longer have to provide it a rule file, and it just figured out the right thing to find without finding our false positives. So
Nice.
it got the defaults right, I guess, from a usability perspective. So if we were to put this now in our pre-commit hook, to finish the thought here, git hooks pre-commit. Okay. That's going to do is it's going to cause it to exit -1, which will cause the hook to fail. And that's going to cause the commit to fail. Okay. So what we're going to do first is we actually have to commit the pre-commit hook, weirdly. So we got to add that, add pre-commit hook. And it's running, and then boom, it did not exit -1. So it didn't stop us here. It should have actually stopped the entire commit process, even though we didn't stage this key, because I'm not going to accidentally commit this key to GitHub today. But what we want it to do is actually exit -1. So there's got to be a -- fail. Oh, I forgot to add the -- fail flag. So now we put this in here, -- fail. Okay. And there, it failed. So it's not even letting me commit now. So it's telling me that it found a secret. So I could wrap this, if I was engineering this for a team, I would wrap this, of course, in some tooling, because they should receive a meaningful messages and not just pig faces and keys. But I think we get the idea here. So we saw a couple of different ways that we can protect these credentials. We saw how to implement this pre-commit hook scanning. And somebody says it's not a real Python tool unless it doesn't install correctly and has emojis in its output.
What was it you said? Pig faces and keys?
Pig faces and keys.
Oh, I love that. I don't know why, but it just sounds fun.
All right. That was awesome.
Well, that was quite a hog through that demo.
What a journey.
What a journey. We made it
realistic
to the end.
depiction.
Yes.
I'm going to go open an issue on that repository now and let the maintainer know that the version in PyPy is not the version that is in Brew.
Interesting. Yeah. Sweet.
And that's how things get better.
Somebody said it was very validating and relatable to see all the failing.
Oh, absolutely. I think we all have that struggle every now and then.
Yep. All right.
Thank you, Andrew, for this demo and this walkthrough and this pain point of how to deal with when things go wrong or not exactly how you planned for.
Yeah, well, thank you. And thank you, Serena, for joining and all the great commentary. Happy to come back anytime. And of course, if you want more of this and you want to see me failing on screen more, the next time that we do the Securing the Cloud class will be at Deadwood, I believe.
Nice.
And you can find info for this class and others at antisyphontraining.com. Got the link up there for you. You can also follow us on Twitch. If you're watching on YouTube, if you're on Twitch, you probably already follow us, maybe, or maybe you don't, but you can. So there's that. And we are about out of time. So I think that's it for today.
Bye, everybody. Thanks, Andrew.
Bye, guys. See you tomorrow. We'll have another AASLR with a topic that I don't know yet, but we'll find out tomorrow.
Kill it, Ryan. Kill it.